Good day, wizards. Welcome to your lesson for integration. Remember, we are continuing from our integration and how we work with integration, the importance of integration. We also learnt about some of the industrial uses. Can you remember some of the industrial uses that we learnt for integration? I can name a few. I learnt about arc length. We could use integration for arc length, and that comes in handy when they work with architectural designs. I also learned that integration will help me with probability where I don't have a definite outcome or event, or the events are too large for me to calculate. I also learned that integration is important when working with area between curves. What else did I learn? I learned that integration is important for distance and acceleration, and integration is also important in terms of volume. How is integration important in terms of volume? It is because volume is hard for us to anticipate or to predict volume. So what computerists have done, or people that are going to look at volume of large objects or large containers, they use integration. By using integration, this diagram will come up in subsections that will make it easy to calculate volume. Integration is also used in various different aspects of physics and technical science, such as kinetic energy and calculating kinetic energy. Remember that we will look at integration as being the opposite of derivatives or differentiation. So you have to learn one section in order to know the other. In other words, those sections go hand in hand, much like addition and subtraction, multiplication and division. Everything has a pair, wizards, and integration and differentiation, they go together. Now, what do we want to look at in terms of integration? We want to look at the rules that will govern integration. So there are a few rules that govern integration. Those rules are the power rule, the sum rule, the difference rule, and the integration by parts. So there are 4 rules that we are going to be looking at, and we're going to look at them individually. We're going to see how they work using an example, and then hopefully by the end, we learn how to do integration by parts. Once we've learned that, we can effectively say that we have learned the rules of integration, and then we can use those rules and do various different examples. We can learn to do shorter examples as well as more complex examples by using what we learnt about integrals. Let's have a look at the rules as follows, as well as the accompanying examples that can go with them.
So wizards, when we work with integration rules, the first rule that we'll be working with is called the power rule. Now, the example of the power rule, it states what is the integral of x cubed or x to the power 3 dx. Remember, dx speaks in relation to the function. So what the question is asking is, what is the integral of x cubed? We can use the power rule where n is equal to 3. So if you can see what we have here, the power rule refers to the following. So in that following power rule, we can say that this rule governs the power rule. What that rule states is that the integral of x to the power n dx, like we have at the question or the example, and that is going to be equal to x to the power n plus 1 all over n plus 1. That seems familiar. Where did we come across that? When we were working with rules of derivatives or rules of differentiation, we said n or x to the power n minus 1, and that was multiplied by n minus 1 at the front. So all we are doing is doing integration, which is the reverse of differentiation. And remember that what we will always add is your constant of integration. Why do we add that constant of integration? We add that because we said that derivatives or a derivative of a whole number is 0. So we need to replace a whole number that could exist. So I want to show you how it looks in terms of the formula. I will have the integral of x to the power 3 dx. Remember, it's in respect to x, which is equal to x to the power 3 plus 1 all over 3 plus 1. And that is how I arrived at the answer x to the power 4 all over 4 plus c. So that is called the power rule. So again, with the power rule, what we are working with is trying to replace the exponents, and we end up with the division, and we always add the constant of integration. The next rule we work with is called the sum rule. Now the sum rule, we use this when we add derivatives. So let's look. The example, what is the integral of cos x plus x dx? The sum rule states that the derivative of an addition will give us the addition of the integrals separated. What can we say? We can say that this forms the sum rule, or it depicts the basis of what the sum rule is. Once we have that sum rule, we can look at the example. The example says the integral of cos x plus x dx. We can separate that and say the integral of cos x dx plus the integral of x dx. We can work that integral. We can use the table above, which you can find in your iWis book or on your worksheet, and we can say that the integral then is equal to sine x plus x squared over 2. Now, where did that come from? The integral of cos x dx is equal to sine x, and then the integral of x dx, following the power rule, we said is going to be x to the power 1 plus 1 all over 1 plus 1, which gives me x to the power 2 all over 2. So that's where the two parts come with my addition, and don't forget to add the constant of integration. Now this sum rule does not only work for the sum rule, but it also works for difference or for subtraction. So wizards, remember that you can use this for addition as well as subtraction. The next rule is the difference rule, which we learned to be exactly the same as the sum rule. So we can say that this formula governs the difference rule. What the difference rule states, if I have an integral of e to the power w minus 3 dw, see how the w changes depending on the variable that we use. Once we have that, we separate the integrals and we say it's the difference of the integral. When you look at the table that's given in your worksheet, you will have the integral of EW is equal to EW. And then if we minus, so minus the integral of 3, we say that this is going to be 3W. Why? Because if I were to differentiate this or to find the derivative, it will be W to the 1 minus 1, which is 0, and then 3 times 1, which would give me 3. So that's how we replace the W, and we don't forget the constant of integration. The last thing we want to look at when we speak about integration is how we combine all of those rules. When we combine the rules, we see that we can work with integration or a larger integration by breaking it down into parts. The example that we have, it states, what is the integral of 8z plus 4z cubed minus 6z squared dz? Now that dz is because we are working with a function in terms of z. We can use the sum and difference rule like we learned, to separate them so we can break up our integrals. What should we be left with? I should be left with 1, 2, 3 individual integrals. So that gives me 1, 2, 3. So I have my 3 separate integrals. The only thing I will carry is my addition and my subtraction. Once I work with that, I can follow the constant multiplication where the number on the outside can be taken from the inside. So can you see this 8z? What I can do is I can take that 8 and bring it to the outside of the integral. Therefore, I have 8 integral z dz plus 4z cubed minus 6 integral z squared dz. Once I have that, using the power rule that I have, remember z is going to be 1 plus 1 all over 1 plus 1. 3 will be 3 plus 1 all over 3 plus 1. The 2 will be 2 plus 1 all over 2 plus 1. Can you see that's how I arrived at my 1 plus 1, which is 2, 3 plus 1, which is 4, and 2 plus 1, which is 3. And what I have then is the addition and the subtraction of my separate integrals, not forgetting to add my constant of integration. Once you simplify that answer by looking and seeing that each number is even numbers, so all I needed to do for this step was divide by 2 to have my simplified answer at the end, not forgetting my constant of integration.
So wizards, we've learned how to use 4 different rules. Effectively, we've learned a power rule, a sum rule, a difference rule, and how we mix those rules together to do integration by parts. What have you learned from them? You have learned to always put your C. C is your constant of integration. What else did we learn? We learned from those examples that sometimes we can break down our integrals or our integration to smaller bits and pieces that make it easier to work with them. This comes in handy when there is a large integration for you to complete. Now wizards, be sure to go onto your iWiz website. As you can see, that website has worksheets for you to complete. Those worksheets are very helpful if you want to progress in your knowledge of integration. Remember that those worksheets have multiple examples that are designed to test your skill, your knowledge, and your required method of doing calculations.